Hey everyone, welcome back to my channel. Before we begin, if you find this series helpful, please like, share, and subscribe to support the channel. We are starting a 0 to interview ready series. So let's begin day 1, session 3. Let's learn together. Remember, this is a quick revision for interview preparation, not a detailed explanation. So let's begin with the topic 1. So the first concept is module. A module is a basic building block in Verilog, just like a function in C or Python. A module describes a hardware circuit. Every Verilog program starts with the keyword module and ends with end module. So moving on to the next topic, which is input and output ports. Input ports receive signals from outside the module, while output port sends the process signals back outside. These ports are how different hardware modules communicate with each other. So now let's talk about the logic data type, the next topic. Topic 3. So logic is the most commonly used data type in System Verilog, which you'll be getting to know in the upcoming videos. So what it does, it stores digital values like 0 and 1 and is used for inputs, outputs and internal signals. So the next topic is writing logic using assign. So what is assign? To build simple combinational circuits, we use the assign statement. Combinational circuit switch does not involve the clock. You remember? So moving on, it continuously updates the output whenever the input changes. For example, assign y is equal to a and operator b creates an AND gate, while OR and XOR can be written using same with the respective operators of OR and XOR. So moving on to the next topic, why we use assign? Why do we use assign? Because it's simple, easy to read and perfect for combinational logic. Since there's no clock involved, the output changes immediately whenever the input changes. So the next topic is building your first circuit. So now let's build our first circuit. And an AND gate can be written using assign y is equal to a and operator b, and an OR gate can be written using assign y is equal to a or operator b. This is the simplest way to describe digital logic in Verilog. So moving on to the next topic, which is common operators. So I think you already know about some basic operators, right? AND operator, OR and XOR. So let us look for some common operators. So ampersand and represent AND. Vertical bar represent OR. Caret represent XOR. Tilde represents NOT. And double equal is used for equality comparison. These operators are used almost everywhere in Verilog coding. So the next topic is, which was the leftover topic in previous session where I forgot to involve that. So let's study about this in this session. So let's quickly cover the leftover topic from the previous session, clock skew. Clock skew is a difference in clock arrival time between two flip-flops. It usually happens because of unequal wire delays or clock routing. If clock skew becomes large, it can lead to setup or hold timing violations. Okay? If the clock skew happens, then setup and hold timing violations occurs. You remember how metastability occurs due to setup violation and hold timing violation, and how these occurs because of clock skew. Okay, so let me continue. If clock skew becomes large, it can lead to setup or hold timing violations, which may affect the reliability of the circuit. So this was for the day 1 session 3. So the upcoming videos will be posted as soon as possible. So this will be the day 1 session 3, the session 4 will be uploaded shortly. So stay tuned. Until then, keep learning, keep practicing, and let's become interview ready together. Bye bye.